All right, so welcome to the screencast for objective number 11. This is going to talk about density and how we calculate density, as well as how density changes as temperature changes. So when we talk a little bit about what density is the ratio of mass of a substance to volume. So it is just the mass divided by volume. It's a ratio of these two units to create this derived unit of grams per milliliter for density. So m equals dV is another way to write it, or V equals m over d. These are all three the exact same equation. They're just solving for each of the three different variables. So the mass is going to be the amount of matter in a substance. The volume is either going to be in centimeters cubed or milliliters, which you remember 1 milliliter is 1 centimeter cubed, so you can use those interchangeably. But that's the amount of space that a substance takes up. So density is a physical characteristic of all objects. It's not going to change if I cut the sample in half or if I double the sample that I have. My density is always going to stay the same for each of those materials because it is the ratio of mass to volume. So if I cut the mass in half, I'm also cutting the volume in half. If I double the mass, I'm also doubling the volume. So it's going to have the same effect. So it can be used to identify unknown substances, fool's gold versus real gold. Real gold is a lot more dense than fool's gold. There is a density video that we are going to watch in class. You can watch it on your own, but we will watch it in class. So density is not constant, though, because it is temperature dependent. So as the temperature increases, volume increases. So the amount of space something takes up gets bigger. Your mass is always going to stay the same. So your top number stays the same, but your bottom number gets higher. That's actually going to lower your density because you're dividing by a bigger number. So density is usually reported to a specific temperature. For example, the density of water at 4 degrees Celsius is exactly 1, but the density of water at 80 degrees Celsius is a little bit less than 1, and you'll notice because the volume is higher. So because I'm dividing by a bigger number here, my number is now going to be a little bit smaller. Buoyancy predicts density. When we think about if something is more dense or less dense, we think about if things are floating or sinking. So density determines how heavy something feels for its size. If you have a higher density than the material you're around, you're going to sink. If you have a lower density, you're going to float. So we're going to watch this video in class, but again, you can watch it on your own if you want to. How do you measure density? For regular solids, you just measure the volume with a ruler, so length times width times height, and you can find the grams by using a balance. If you have an irregular shaped solid, you can't use length times width times height. Or if you have a liquid, you've got to use milliliters. So you've got to use the water displacement method, where you subtract the amount of the new volume of water from the starting amount of water, and what you're left with, how much it rose, is the volume of that particular irregular solid. We're going to do a lab with regular, irregular solids and liquids. So for gases, we tend to measure density in grams per liter instead of grams per milliliter, which is perfectly fine to do. It's just when you see gases, they're going to be reported in grams per liter. So discussion, will it float or will it sink? If you're talking about regular air, so an air is a mixture of all sorts of different gases, and here's the density of air, 0.0012. Will helium float or sink? Helium has a smaller density, so it is going to float, which is why helium balloons float. Will oxygen float or sink? Oxygen is going to sink, so pure oxygen will stay down towards the bottom. Ethanol, float or sink in water. Water at 20 degrees Celsius, the density is about 1.99. Ethanol is going to float in water. Ethanol would float, it would be on top. Would aluminum float or sink? Aluminum is going to sink. And you notice that the density of ice is a little bit less than the density of water. Of liquid water. We're going to talk about that during our water project. But water is the only solid we know of that does that. So here's some examples. We're going to calculate these in class, but you can feel free to work these out. If the mass of a substance is 9.26 grams and its volume is 6.84 milliliters, what is the density? So D equals M divided by V. You just divide those. If you know the density of an object is 9.2 grams per centimeters cubed and the mass is 4.2 grams, what's the volume? So here you're solving for V. And in example number 3, you're going to solve for m. What is the mass in kilograms? So you're going to solve for the mass in grams, but then have to convert it to kilograms of an object with a density of 19.4 grams per milliliter and a volume of 4.28 milliliters. So we will solve these 3 problems in class just to make sure that you guys can all solve density problems. There is a video on EduCreations, a density video that I have created on EduCreations. So we're going to solve problems in class, watch the videos, and do 2 different lab activities dealing with density.